Welcome to Third Angle, where you find us navigating through the night sky like Iron Man. I'm your host, Paul Hames from industrial software company PTC. In this podcast, we share the moments where digital transforms physical and meet the brilliant minds behind some of the most innovative products around the world, each powered by PTC technology. Have you ever wondered what it would be like to be a fighter pilot like in the Top Gun films? In the past, when flying a high-speed jet, the pilot would have to look down at the dials on their dashboard to see critical readouts such as altitude and remaining fuel levels. More modern aircraft contain a display fixed in the cockpit in which symbology, i.e. lines and markers, are overlaid over the windshield, allowing the pilot to see all the information they need without having to look down at the dashboard and away from piloting the plane. BAE Systems have taken this a step further by creating the Striker 2, a helmet-mounted display which enables pilots to see symbology overlaid onto the real world in 360 degrees. Similar to Iron Man's helmet, the fully HD color display gives the pilot instant information about their surroundings. For example, it might overlay a red symbol over an incoming aircraft to warn the pilot that it is hostile. It contains pioneering new features, including a night vision mode and a 3D audio system, which uses spatially positioned sounds to communicate to the pilot where other aircraft are. We sent our producer, Hannah Dean, to the BAE Systems simulation facility at Rochester in the UK to meet Nigel Kidd. Nigel is the product director for the helmet-mounted displays at BAE Systems and told Hannah about how the Striker 2 works to make pilots safer. She even got to try the Top Gun style experience herself by wearing Striker 2.
Oh wow! I can literally see when I move my head wearing this helmet, I can point it down towards my feet, and it's as if I'm looking through my feet and the aircraft and looking down below me to the fields and houses and roads to below.
So I'm Nigel Kidd. I'm the product director for helmet-mounted displays here at BAE Systems in Rochester. I've been with the company for 26 years now, just over 26 years. Started as an apprentice. I grew up locally and was interested in engineering, familiar with this site being a centre of excellence for high-end engineering, electronics engineering, and I look after all of our head-mounted display product developments. We're in the simulation facility here at Rochester, so this is an area where we have simulators where we can try out all of our equipment. We've got fast jets, got helicopters, we've got commercial aircraft here that people and pilots can get in to evaluate our systems.
I'm Paul Harrison. I manage the flight simulation facility here at Rochester, and my role is mainly to develop and maintain these simulators, but also take our customers and visitors through to allow them to really experience the products, capabilities that we produce here and what they do for the end pilot community. And we do that everything from STEM work all the way through to pilot, government and industry. Here's some pictures of the airfield as it started. So this is after the airfield was started being built in 1930. Got this picture of the first aircraft to land here, which come from Gravesend Airport. That was early gyrocopter aircraft here. The RAF using it for fighter training in 1938. The hangars that you can see today actually being built in 1940. And here's an image of 4-engine Stirling bombers being produced in that space. And ironically, this space here is where our new current production facility is. Just rather than producing full-size aircraft, it now produces flight controls and avionics and helmets and HUDs and mission computing and all the things we make here in the same space. And the airport is, as it sees today, as a general aviation training facility and place where things like the air ambulance can come and go, and military aircraft helicopters come and go for fuel. But yeah, it's got a rich history of aviation from here from 1930 onwards.
So people who have seen like the Top Gun films, people have seen that. They will have seen, what the pilot looks through on his head-up display fixed in front of the cockpit. So what the pilot used to get was that sort of information. So it was what we call symbology, which is basically lines and markers overlaid onto the real world. So as the pilot looks out into the real world, there is maybe a symbol over another aircraft, or there's some speed and altitude information which is presented in front of his eyes, so he hasn't got to look down inside the cockpit. When you go to Striker 2, going from that old analog technology to the modern HD technology, which also has gone from basically a black and white display to a full colour display, we're able to provide far more information which is relevant to the pilot. And the best way of probably describing that is, if you watch the Marvel films, Iron Man, what Robert Downey Jr is looking through when he's looking through his helmet and he sees symbols overlaid on the real world, giving him all sorts of information in colour, which then he's looking at that. He's not looking at anything else. He's looking at the real world and the information which that display is giving him while he's flying around at speed. That's the kind of thing that Striker 2 does. It used to be a case of what you could display was limited by the technology of the display and the information that the aircraft was able to provide to the helmet for it to display. So it was quite limited. Now we can display all sorts of stuff. We could fill up the display with all sorts of symbols and information. And what we need to remember is that the pilots who are using this are in a stressful situation, and this is all about providing information to the pilot which makes their job easier. It needs to be intuitive so that they don't have to think about what they are doing. The information makes it straightforward, So a simple example of that is the older display, as I say, was black and white. It was actually green and nothing. So it's like all the images were in green. So if the pilot had a symbol which came up, which was a symbol for a warning, it would be green. So they'd have to look at it, and then they would have to think, okay, well, that's a warning symbol. I need to take action in this certain way. In Striker 2, we can just put up a red symbol, and they know that red means danger, and it grabs their attention, and then they do what they need to do against it.
Did you want to have a go at flying it and see it move dynamically?
I can give it a go, why not?
Just want to have a seat. Now they're split up a bit. You can now see there's a blue one,
yes,
which is a friend, a yellow one, which is currently unidentified, and a lot of red ones. There's a couple of blues out there, but what it's really doing for you is, rather than you having to work out what each shape means, the recognition of something being red instantly tells you it's a potential threat. If it's a blue, it's a friend. Yellow, you need to work out what it is. But the key thing is where they're positioned is physically where they are relative to you. But now you see that's all the way off to there. So in real time, it's giving you that situational awareness where things are around you. So you don't have to think about it, you don't have to process it, you just know that's over there. And that's what it's doing, it's reducing your workload and taking you straight to decision-making points.
Yes.
If it was night time outside, it would look like that. So now, out the window, you can see lights from towns, but not a lot else.
Yes.
But you've only got your symbology. But if we give you the night vision system, you can now see night vision scenes come on.
Yes, I've got mountains in front of me.
Yep.
I can see a lot more.
So you can see at night with it. You can scan the night sky in the same way you'd scan the day sky.
Yeah.
When you're operating at night, the pilot needs to be able to have that imagery that the helmet can provide, but also wants to be able to see the outside world. So previously with Striker 1 and other systems, the pilot would have to clip on night vision goggles. And those night vision goggles are heavy, they're like 0.5 kilo, they hang off the front of the helmet, so they unbalance the helmet quite significantly. These aircraft, they can regularly pull at sort of 9 Gs, so that means that everything becomes 9 times heavier, including your own head. So the neck strain that can come from that is immense, and generally when pilots are flying with goggles, they limit the G that the aircraft can pull down to about 4.5 G, which is not ideal for anyone. So what we've done with Striker 2 is included a digital night vision sensor. So those old bulky analog goggles are thrown away, they're not required anymore, and we're able to provide that night vision image over the entire visor that the pilot's looking through at the flick of a switch.
If I did this, you've probably got a sound in there now.
Yep, I've got like a constant beeping
tone.
sound.
But that's
tone,
tied to one of the aircraft, so it's coming from a certain direction.
Yeah.
If you move your head in that direction, when the sound's in front of you, you'll be looking at the aircraft it's coming from.
Oh, I see. So I'm hearing that in my, sort of to my right here.
Because it's spatialised where the source is.
One of the things that is a growth option for Striker, and we can give a demonstration of in our simulator here, is a thing called 3D audio, where we can spatially position sounds very accurately around the person. And it's more than just stereo. So we can do stereo, obviously, but this is within a fair degree of accuracy. We can position sounds around the pilot such that if we give them a symbol on their display, we can make a sound come from exactly where that symbol is in the real world. So again, it's about grabbing attention and making it intuitive, not having to think, where is that? Okay, I've got a tone, where's that tone coming from? It's over there and can look straight at it. This has historically been the preserve for what we would class as high-end fast jet aircraft. However, the utilisation of what we're able to display now means that what we're really doing is we're able to provide information which can keep people safe, reduce stresses in stressful environments, reduce the chances of mishaps. So this type of technology moving from the high-end fast jet fighter aircraft down into some of the other more utility aircraft, both military and non, we absolutely see that being the case. And the technology which we're developing as part of this latest head-mounted displays, that has applications, not just aviation, but for keeping people safe in all sorts of environments, soldiers, ships, understanding where shipping lanes are and what other ships are out there. Armoured vehicles, for example, where you have to see through the armour and have situational awareness. There's lots and lots of opportunity for this type of technology, this type of system, to be transformational in a number of arenas. The commercial world is full of discussions around augmented reality and extended reality and mixed reality. We've been doing that here on site at Rochester since before those terms were coined. We developed the very first head-up display here on site at Rochester in the 50s, 60s for the Buccaneer aircraft, and that was augmented reality for the very, very first time ever. Talking about the future, we're always looking at what the next thing is. So we are already working on what comes next. So we're looking at the Tempest program, the GCAP aircraft that will come in the 2030s. And what does the pilot of the future need to do? And what do they need of their display system? What technology and capability can we provide as a part of that? So I guess there's two aspects of it. One is we see that pilot of the future probably more as a mission commander than as a pure pilot. So there will be AI systems helping them fly the aircraft. What they will be doing is they will be controlling unmanned aerial vehicles around them, drones potentially around them, in a very data-rich environment, again, where there's even more information flowing all the time. So there'll be a battle space commander as opposed to just a pilot. So how they need to utilise that information is key. And then secondly, we've already been looking at, for that type of future platform, things like a virtual cockpit environment. So instead of, at the moment, and in our simulator, you can see there are what we call head-down displays, basically big television screens in the cockpit, as well as head-up displays that you look up through the front, as well as what you can get on the helmet. Imagine that cockpit just as a blank environment, just black, nothing there at all, and the helmet is able to provide everything. So all of your map information, all of your speed gauges, everything provided virtually on the visor of your helmet. And instead of having to change boxes and be limited with a display in a certain area, you can virtually move displays around or have different set of displays depending on what type of mission's being performed. So a virtual cockpit is definitely one of those key things for the future.
That was Nigel Kidd and Paul Harrison from BAE Systems. Striker 2 is considered one of the world's most advanced helmets. It not only protects the pilot's head, but it also displays mission-critical data in colour on the pilot's visor using augmented reality. Developing a helmet that provides protection and getting all the electronics into it is no mean feat. And as you can imagine, one of the most complex parts of the helmet is the carbon fibre shell. This is where PTC's 3D CAD solution, Creo, comes into play. Time to meet our expert, Brian Thompson, who can tell us more. Brian, BAE Systems used Creo's style tool, which is the ISDX module. Can you give the listener an overview as to what the tool delivers and how it might aid a complex product such as Striker 2?
Sure, would love to. ISDX is PTC's top-tier surfacing module. It gives design engineers and surfacing experts, frankly, very, very precise control over the flow and management of surfaces, starting with curves and building all the way out into controlling all the intricate connections between surfaces so that they can achieve a very, very nice aesthetic effect, while also, and this is really the important part for a company like BAE, while also creating those surfaces parametrically. Like, the real power here actually is not just in being able to create what we would call Class A surfaces, super high quality surfaces intended for the exterior of any product. The real power is that you have a highly technical application here in the development of this helmet, and what's underneath has to be designed also with incredible precision and think safety in mind for the pilots. And the design techniques for what's inside the helmet might be very, very different, might use very, very different tools. And the power of ISDX being integrated, sure, it's got these great tools for advanced surfacing, but the fact that it's integrated so deeply into Creo and provides real parametric surfaces as a result of the design techniques using ISDX that can be linked and associatively developed alongside other types of geometry that are built for purposes of designing the other parts of the helmet, that's where the real power comes. And I'm sure BAE has really leveraged the connective tissue between, internal surfaces and internal structures and the beautiful external surfaces of this helmet. So it's a really great application, and we'd love to see it.
Yeah, and I think, Brian, as someone that many, many years ago worked on the styling of a face mask and for one of the military customers that we have here in the UK, I know how tough it was to do that without the ISDX capability at the time. But I think the other thing that you get with ISDX is also all of the information about the quality of the surfaces, the reflection lines, the zebra striping that we do to just show the connections and the accuracy, which I think gives, again, the designer confidence that the aesthetic is exactly what he's expecting.
Yeah, you're right. There's a whole suite of tools in there to make sure the design engineer can really see clearly how the surfaces are flowing. Sometimes your eye can be confused, and so we actually, as you said, we have these great plots that we can overlay onto the surfaces to make it obvious how the geometry is flowing, so they can really get a sense of what it will look like in certain lighting and in reflective environments and so forth. And it's just part of what people that are surfacing experts expect. And again, because it's there integrated into the tool, you can instantly see how the flow of the surfaces are changing with these different visual effects as you do your design work. So it's really, really great set of integrated tools.
Huge thanks to Nigel Kidd and Paul Harrison for showing us around the simulation facility at BAE Systems in Rochester. Please rate, review, and subscribe to our bi-weekly Third Angle episodes wherever you listen to your podcasts, and follow PTC on LinkedIn and Twitter for future episodes. This is an 1860 production for PTC. Executive producer is Jackie Cook, recording by Hannah Dean, sound design and editing by Clarissa Maycott, and music by Rowan Bishop.